Okay, so last lecture में हम लोगों ने we have studied the buck chopper, analysis of buck chopper. Today we will see the various type of chopper. Basically these choppers are used to control the DC motor. That means we have to have control in all four quadrant, like forward motoring, forward braking, reverse motoring, and reverse braking. So for that we have various type of choppers, and in today's lecture we will discuss these choppers, right? So let us define. There are basically five type of choppers, like class A, class B, class C, class D, and class E chopper. These classes are meant on the basis of the voltage and current which we are getting at the output. For example, let us consider this class A chopper. We have already studied this chopper. This is also the step down chopper or buck chopper we have studied. In this, you can notice that only first quadrant operation is possible. That means whenever this switch is on, you will get the output, and when this switch is off, you will have this freewheeling action. Means the current could have uh, at least, I mean, it is always positive. Current is always positive, as well as voltage is also positive. So you would have operation in first quadrant, right? Now next is class B chopper. This is also called type B chopper. Some author refer like class B, some say that type B. Both are the same thing, right? In this, we have one switch SW2 and one diode D2. Why I am doing numbering in this? Because in the class E chopper, we get means all four quadrant operation, and that is achieved using these choppers. That is why the numbering is like this, right? So this is switch 2 and this is diode D2, right? This type of chopper, that load must contain the DC voltage. This is the requirement of this, because why this chopper operate in second quadrant, that is the braking operation. The speed of motor is to be reduced, so the current will flow in opposite direction. Current will flow in opposite direction. For that, this voltage, that is the load voltage, must be greater than the supply voltage. Load voltage must be greater than the supply voltage. Then only this is possible. It will flow the current in this particular direction. So output is equal to E plus L di by dt, and the current will, when the switch is on, current will go like this, and when the switch is open, it will go like this. So when the switch is on, current increase, and when switch is open, current is feeding power to the, means it is going to the supply, so it would decrease. Means in all the cases what you get, you will get the positive voltage, but the direction of current is in this, that means opposite. So in class B chopper you would get the forward braking operation. Means voltage is positive, but the current is negative. Whether switch operate or diode conduct, in both the cases the direction of current is like this. This is also called the boost chopper. It is also called the boost chopper, right? So let us move to the other type of chopper, that is the class C chopper. See, this class C chopper is made using class A and class B chopper. When we combine these two chopper, we get class C chopper, and since we are combining, that means we will get the first quadrant as well as second quadrant operation. Means voltage will remain positive, current could be positive or it could be negative, because in class B current direction is negative, in class A current direction is positive, but in both the cases voltage is positive. So how this could be made? I have drawn this using this red color pen. This, if you remember, it is your buck chopper or type A chopper, and across the load there is freewheeling. So this is this highlighted portion which is drawn in red color is your buck chopper. So you will get this first quadrant operation. Now when this switch is on, output is VDC. When this switch is off, current is freewheeling through this. So voltage is all the time positive and current is also positive. Now when S1 is not operated, only as switch 2 is operated, switch 1 is permanently off, switch 2 is operated. So current will flow in this direction. As the switch is open, the current will go to the supply through this diode. You just see this. That is why I have taken the numbering like this, so that you can easily understand the things. Means class A chopper and class B chopper combinedly they operate as class C chopper. Now what happened? When this diode, this switch is off, current will flow like this, current will flow like this. It will go like this, isn't it? And when this switch is turned on, the current which was going against the supply, it will circulate in this, it will circulate, it will freewheel through this, right? So you will get the negative direction of current, but the output voltage remain positive. So that is class C chopper. That is class C chopper. Clear? Now come to the class D chopper. In this case, voltage could be plus or minus. Voltage could be either positive or negative, but the current is always positive. Voltage could be either positive or negative, but current is always positive. How we can achieve this operation? See, whenever these two switches are on, that means switch 1 and switch 2 is on, the current will flow in this direction, and your output voltage is like this, VDC. Clear? Now when these two switches are off, current, as the load is RLE type, the inductor develop polarity in such a way that it will continue to flow in this direction. Means current is feedback the supply, right? Even though it is positive. Applied voltage is negative, as this terminal is connected here. So this is VDC, this is 0, as you are measuring the voltage in this direction. So it is treated as minus VDC. It is treated as minus VDC, whereas this is treated as VDC, and VDC minus VDC. But the direction of current is always like this, right? When switch 1 and switch 2 on, it will flow like this, isn't it? And when these two switches are off, current will still flow in this same direction. It will still flow in the same direction. Fine. So direction of current remains same. And we can also calculate the output voltage by simply equating the volt time balance equation. Let us say the average output voltage is V0 and this is appearing for the duty cycle of for the time period of T. So V0 into T is equal to VDC into T on plus VDC. This is not the way. Let me correct this. Just give me a second. This is this is this is T off. This is T off. For the duration of on period, VDC would appear at the output, and for the duration of off period, when D2 and D1 are conducting, we will get the negative output voltage. So it is minus VDC. Now once you calculate as the T is equal to T on plus T is equal to T on T is equal to T on plus T off. So we can put T off is equal to T minus T on. Once you do this, you will get output voltage is come out to be 2 alpha minus 1 times VDC. So as alpha is greater than 0.5, output voltage is positive. 50% से ज़्यादा देर को अगर T1 S1 S2 को ऑन कर देंगे, we will get the output voltage positive. If duty cycle is less than 0.5, you will get the negative output voltage. So this is the principle behind class D chopper. So what we have seen so far, this is somewhat unipolar. Unipolar means the polarity of the voltage is same. Means all the time you are getting the positive. Voltage. Whereas here the voltage is changing. From plus VDC to minus VDC, right? So this is bipolar operation. Clear? Now come to the class E chopper. Basically what we required. Our motor has to be operate in all the 4 quadrant, means forward motoring, forward braking, reverse motoring and reverse braking. For that we must have a chopper which can operate in all 4 directions. So we have class E chopper. How it looks like, we will see in the circuit. The circuit is like this. There are 4 switches, S1, S2, S3, S4, and each switch is having diode in anti-parallel of this. Each switch is having diode. Let me take this color. Okay. Each switch is having diode anti-parallel of this. Right? So the direction of current flowing through the diode is opposite of that particular switch. Now let us see how it could be operate in all the 4 quadrant. Let us see how it could be operate. See, whenever this switch 1 and switch 4 are on, you will get positive voltage. Let me also make the direction of voltage. This is the output and this is I0. So you will have positive voltage and positive current. Now when switch 1 is off, so in that case the current will flow like this, switch 4 to D2. means when switch 1 and 4 on, the current will flow like this. When only switch 4 is on, the current will freewheel through this. So you can notice that switch 4 has to be operate all throughout. Switch 4 has to be operate all throughout, and switch 1 is to be operated, means it should be on and off to get the variable DC voltage. Clear? And switch 4 has to be turned on all throughout the time. Now, for getting the second quadrant operation, that means voltage is positive but current is negative. Voltage is positive but current is negative. How we could have this operation? In this case, your switch 2 needs to be operated, means it should be turn on and turn off. It should be turn on and off. Clear? So, when switch 2 and D4 operate, when switch 2 and D4 operate, means conduct, the current will flow like this. The current will flow like this, and you must notice that there must be a back EMF as well as inductor, so that the net voltage is higher than this. So what happens when this switch 2 is open? When this switch 2 is open, current is feeding supply, and you will get the braking operation through D1 D4, through D1 D4 like this. Once again I am drawing. It is like this. It is like this. Current is negative. Current is negative. Right? And voltage is still positive. Voltage is still positive. यही तो चाहते थे. This is what we want. Now, and also you can see here what we did. We basically connected two class C chopper to get this class E operation. Now for third quadrant operation, means your voltage is negative, V negative, and I is also negative. So for that, what we do, we just make the switch 3 operated. That means it will keep on turning on and turning off, and this switch 2 is permanently on. Switch 2 is permanently on. So what happened? The negative terminal is connected here. Sorry, the positive terminal is connected here, and we are measuring in this direction. So we will have negative voltage. At the same time, the direction of current is also negative. The direction of current is also negative. It is flowing like this. Huh? It is flowing like this. Current is flowing like this. Here to here to here, then switch 3, then this. Direction is this. Opposite of I0, so it is negative. Now when switch 3 is off, when this switch 3 is off, the current will freewheel through this diode D4 as SWT is permanently on. So you can notice this switch 2 is permanently on, and here what happened? Switch 4 was permanently on. That means all lower devices are overutilized. All lower devices means SW1 and SW4 are overutilized, whereas SW1 and SW3 are underutilized. That is the problem with this. This is overutilized, whereas 1 and 3 are underutilized. But at the same time, the advantage is this: the device is having less stress as compared to bipolar, because there the voltage change from plus VDC to minus VDC, but here voltage remain constant. Voltage remains constant, means either positive or negative, either positive or negative. So that on this basis we can see what we do, that the control strategy could have two types. It could be unipolar. It could be unipolar. Unipolar means the voltage is either voltage is positive. The voltage is positive. Here voltage is positive, and current can vary from plus to minus, plus I to minus I. Or other way we can say the voltage is negative and current is changing, means at a time voltage is either positive or the negative. That is why it is called the unipolar. वोल्टेज जो है हमेशा जो है या तो पॉजिटिव रहेगा या नेगेटिव रहेगा, और जब ऐसा होगा इसका मतलब जो हमारी करंट है वो करंट चेंज हो सकती है, पॉजिटिव या नेगेटिव, मीन्स ये ऑपरेट करेगा पहले या दूसरे में, या फिर ये ऑपरेट करेगा तीसरे और चौथे में. रिवर्स मोटरिंग, रिवर्स ब्रेकिंग, फॉरवर्ड मोटरिंग, फॉरवर्ड ब्रेकिंग ऑपरेशन. बट if we operate it like this, means bipolar direction. Bipolar means voltage could be plus VDC or minus VDC. In that case the stress is quite high. At the same time the ripple in the output voltage is plus VDC to minus VDC. So that is not good thing. So what we do, we use unipolar operation to operate class E chopper. Now we have also seen, in case if it is a unipolar, the lower devices were overutilized and the upper devices were underutilized. To overcome this, what we do, we use the modified unipolar control. We use modified unipolar control. In this case what we do, and this is applicable for the industrial available choppers, we find the voltage for the two switching period, means the averaging what is used over the two switching period, not for the single switching, right? Let us say these are the two consecutive switching period. In this, to get the positive output voltage, what we do, we operate channel 1, switch 1 is more than the one time period, right? All throughout the, see the time period is divided into 4 parts, means each is representing the 25% of the time period. So it is operated as 5 period, means 125%, right? At the same time, switch 4, this, one thing you should remember, that switch 1 and switch 2 cannot be on simultaneously. That means they have to operate in complementary fashion. Means whenever one is on, it has to be off, and whenever this 2 is on, one has to be off. And the same case is for 3 and 4. Both switches cannot be turned on simultaneously, because in that case there will be short circuit, and that will destroy your device as well as battery. So let us draw the this. We have made this switch 1 like this, and switch 2 has to be complementary of this. So during this period it is off, and then it is on. Likewise, switch 3, that is this, is operated 25%. Whatsoever you have increased here, you should decrease the upper device by the same value. So it is operated for this duration for the entire two switching cycle, for the entire two switching cycle up to this point. It is operated like this. One is extended by 25% and three is reduced by 25%. 25% is the example. You can take 50%, 75%. It is totally up to you, depending upon the requirement of output voltage. Right? To have more positive, you have to make the switch 1 is on for the long period. Now, what would be the output whenever this switch 1 and switch 4 conduct? You will get plus VDC. You will get plus VDC whenever these two switches are on. Whenever these two switches are on, S1 and S4, S1 and S4, whenever these two switches are on, you will get the positive voltage. So you will have this value. One thing you should notice that the chopper frequency is 1 by T, whereas the device frequency is half of that, right? Device frequency is half of that because the device is switched over the 2 time period, whereas chopper frequency is T, device is operated over the twice of the time period. So frequency of the devices would be reduced. It would be switched 50% as compared to the normal switching, which is carried out at the on the basis of single switching period. We have taken the two switching period for averaging, so device frequency get reduced by 50%. Now to have the negative voltage, switch 1 has to be triggerless, means this time if you remember, for getting the positive voltage, more positive voltage, switch 1 was trigger 25% more, and for getting the negative voltage more, what we did, we trigger switch 3 25% more. So it is operated, switch 1 is operated here and switch 2 is complementary of this. Switch 2 is complementary of this. And switch 3 is operated like this. 1 and then 50% is this. And switch 4 is complementary of the 3. Switch 4 is complementary of the 3. So for getting the negative voltage, we have this. And whenever this 2 and 3 operated, we get the negative voltage. Look at this, 2 and 3. 2 and 3 operated, 2 and 3 operated, we get the negative voltage. We get the negative voltage. Right? Negative voltage we are getting. And this switching is 50% of the bipolar control. The advantage is this. And ripple are also 50% reduced. Ripple are also 50% reduced as compared to bipolar. So these two methods are used to control the chopper. I hope all these things are now clear to you. In case if you have any doubt, don't hesitate to write in the comment box of YouTube channel or direct message to me. I have already shared my WhatsApp number as well as my LinkedIn ID. I also shared my Insta ID, and this is the Power Electronics channel, and all these lectures are available on this, so you can go through these lectures to improve your fundamental, to clear your fundamental in the field of power electronics. In case of any doubt, please do commenting.